In this video, I'd like to continue talking about using the Pythagorean trigonometric identity to solve various problems. And in this problem, we have an angle located in quadrant 4, and we're told the sine value, and we need to figure out the cosine value. Now, in the past couple videos, we looked at using that identity that the sine squared of the angle plus the cosine squared of the angle is equal to 1. We take the value for sine of our angle, this minus 24 over 25. We square it, we add it to the cosine squared of theta 1 is equal to 1. And we essentially solve this formula for the cosine of theta. We subtract this fraction here on both sides, and we simplify everything. We find a common denominator after squaring this out, and then we take a square root of each side to cancel out this square. And at that point, we just determine if it's the positive or negative solution based on what quadrant it is actually in. Now, this method is completely valid and often arrives at a solution fairly quickly, but there is an alternate method that we can consider. And the alternate method is to essentially construct a picture. We need a coordinate plane here, and we're told that we have an angle down in quadrant 4, and we are told information about the sine of that angle. So remember the definitions for trig functions using right triangles. We have SOHCAHTOA, and we know that the sine of an angle is the side length opposite the angle divided by the hypotenuse of the triangle. And in this case, we're told that the opposite side is negative 24 and the hypotenuse is 25, and the negative just tells us that we're going downward, but the actual length of that will be positive. So we are in this fourth quadrant, and we can draw in this triangle, which will have a hypotenuse of 25 and an opposite side length of this angle here of 24. And from here, we have a right triangle, and we can figure out this side length here using the Pythagorean theorem. Since if we call this, let's say a, we have a squared plus b squared, which is 24 squared, is equal to the hypotenuse squared, or 25 squared. This is just the Pythagorean theorem. We have the two legs, we square them, we add them together, and it's always equal to the hypotenuse squared. So we can figure out this side length here and then use the cosine definition, which is that the cosine of the angle is the adjacent side divided by the hypotenuse, and then just determine whether or not the cosine is positive or negative in whatever quadrant this is in. And since this is in the fourth quadrant, we know it's going to be positive, since if we had the unit circle and some point on the unit circle, we know that the x value is the cosine of the angle, where y is the sine of the angle, and x values are positive on the right half of the coordinate plane, and y values are positive on the top half. So we can use the unit circle just to determine if we are dealing with a negative or positive sine or cosine. And if we simplify our equation, we would have a squared plus 576 is equal to 625. We can subtract 576 on each side so that we find a squared is 49, and taking a square root of each side, we would get plus or minus 7. And since we're in the first quadrant, we know that this a value is in the positive direction. In this case, the plus or minus isn't referring to the physical length of this, since that is always positive. This, you can think of it as referring to the direction. If it was drawn over here, then it's in the negative direction, 7 units. But we know that the a value must be positive. So in this case, a is equal to 7. And we can now use trigonometry. We can use this definition that the cosine of our angle, this is theta 1, is the adjacent side, which is 7, divided by the hypotenuse, which is 25. And had we used this method here of using the Pythagorean identity, you can check this, but we would end up with this exact same answer. So we can either use geometry and the Pythagorean theorem and determining the sine using the unit circle, or we can use the Pythagorean identity, though in both cases we do need to figure out the sine based on its quadrant and this unit circle.